Hi, I'm Damien Harkin. This is Chapter 2 for building a parametric sheet metal workbench. In this movie, we will attach geometric constraints and parameters to the model to be able to drive the length and width and height of the bench. Now we want to parameterize our model so that we can modify the width or depth. If we go to the mechanical browser, we can add parameters. So I'm first of all going to create parameters for all the dimensions I think that I'd like to change. So the width of the model, that's currently 1000. Add a new parameter for the depth from front to back, that's currently 700. The thickness of the workbench from top to bottom, which is currently 100. And the splashback. I'm doing it in this order. We could create the constraints first, but I think it's nice to define the parameters first. And then when we attach a dimension constraint, we can use these expressions to control the geometry. So now we can go and look at the constraints toolbar and we can start attaching constraints to the model. First of all, I want to fix the origin of the model. So we designed this so that the workbench is sitting at the origin, the top surface of the workbench, and the two surfaces at the back of the splashback, which are going to be fitting into the corner of the room. So those three surfaces will never move. Those planes will be maintained. Next we can attach a distance constraint, and this will be for the width of the thing. From that side. Now if you press the tab key, you can push through the surfaces to the last surface and select that one, and we see it comes up with 1000. That's the right number. But rather than storing it as 1000, we can use the parameter. So we've already created a width parameter, so we'll apply that parameter to that distance. Now we'd like to fix the distance from front to back. Tab through to pick the right surface. 700, but rather than storing it as 700, we've got an expression called depth. The thickness of the workbench from top to bottom. Again, we use the tab key to push through to the bottom surface, accept the 100, but then change it and call it thickness. Now here's a place where we will use the same parameter in two places. So the thickness of that splashback is 30, which we've called back thickness. And we can use the same parameter on the side splashback. What else? The little lip underneath should be controlled as well. Now I made that 30 mil, and we could use that same parameter just as an example, so we will use back thickness to control that distance as well. We'll do two of them at once and then change the name afterwards. Now let's set the height of the splashback. In this case we're snapping to an edge, so we can set a distance between a face and an edge. And it's currently 350. The little lip on the back of the bench, that should be aligned with the kink on the front face. So again we can select a face and an edge. If you want to check what a constraint is pointing to, you can click it in the mechanical browser, and it lights up on the model, so you can see the two surfaces that are constrained. Now here I'm going to try to constrain that same surface on the side splashback. That face to that front edge. But straight away you see in the mechanical browser that coincident constraint has gone blue. The reason it's blue is because it's already constrained. So it would be over constrained. We can add some constraints to hold this angle at the top of the splashback. I'm not going to change that, it's not a parameter that I'm going to vary, but it's nice to lock it in and force that will always maintain 135 degrees. Save the model. So now let's test our model by changing the parameters, and we'll see what happens. Set the width to say 1200. Yeah, looks good, it got bigger. Let's change the depth to 600. Okay. Thickness of the height of the splashback, make that 200. Have a look, something's gone wrong. There's a couple of surfaces which have not been constrained. We didn't pick them up, and so they haven't changed when the rest of the model has changed. Okay, so we haven't saved this. I can undo, so we do some undos and we get back to the original model. So now if we have a look at those little surfaces, you can see the way I created the model, that was a separate plane was created. Now the whole back face there has been constrained, it's just this little bit that's not. So if we do a coincident constraint and force that to be coplanar with the back edge, that should pull it into alignment. And the same over on the other side. Now I've saved it, I'm very brave. Should test it first before I save it. Let's try changing the dimensions again and see what happens. And it's looking pretty good. So now we've got a parametric sheet metal bench which we can tune up to suit different projects depending what we need. So that's the end of chapter 2.
Download the free trial version of BricsCAD at www.bricsys.com and check it out for yourself.